Hello, everyone, and welcome to the redo of my Tech Talk. For those of you who don't know me, I'm Troy Wiegand. I am the CS Department's Thursday night tutor, and I'm actually put my glasses on. Thursday night tutor, and I'm extremely qualified in this subject matter because I said so. So, let's go ahead and get going. I so for those of you that were at the tech talk that I had on the 20th, I recorded that by accidentally muted the audio um, at the beginning and never unmuted it. So here we are, living life now, and I'm just redoing it because I want to have this resource out there. So let's get into it. So here we are, command line wizardry. So, some shells that we're going to talk about. Also, I am on this screen, right here, playing the video from last time so I don't forget anything. So if you ever see me like hardcore look down somewhere, it's because that's what I'm doing. Okay. But yeah, command line wizard. So some shells we're going to talk about. We're going to talk about seashell, specifically TC shell, which is a flavoring of seashell, bash, and zish. So, a little bit of a history lesson. So, people were using ways to interact with their computers before in text ways. By 1979, Stephen R. Bourne really knocked people's socks off with Bourne shell, just referred to as shell. Pretty neat. Has a lot of the basic stuff that we think about, but still a lot to be desired in terms of interaction and humans using terminal more funsies, I guess. That whole concept is missing. Next, you have your 10x seashell. So someone basically was like, okay, that's pretty cool, but I'm going to do this in C. That's why they call it seashell. A couple of years later, they came out with their enhancement that is TNX shell. TNX stands for something cool, important. Already forgot. If you want Thomas or do nothing to edit your default, this is what your prompt looks like. Pretty cool. Born again shell. So basically, someone took born shell and made it a lot better. Called it born again shell. We call it bash. Again, a lot of I'm going to assume this that our level of knowledge here is going to be a lot of revolving around Thomas. This being for Butler University talk. Thomas is the server here at Butler, currently running Ubuntu 16.04, and your default login shell is the TC shell, which is that slight improvement on C shell. This is what it looks like. And then here is Z shell, and this is actually the default prompt as it looks when it's on Big Dog, actually. Big Dog being another one of our computers, pretty powerful, cool stuff. Yeah. Here's this nice little family tree I found. So yeah, where there's this Thompson shell in 71, and that kind of gave birth to the Bourne and the seashell. And kind of how things came out of that. I would say probably the most popular shells in use now, then you'll see use on machines are probably bash, TC shell, or zish. There's also PowerShell, but I don't want to talk about that because that's for Windows-based systems that are lame. But yeah, so like, for example, if you are running a Mac, the default for forever on your terminal was bash up until this latest patch of Catalina. I don't know what the numbering is. It's like 10.15 or something. I don't know. introduced Zish as the default. And again, our best friend Thomas here is running TC shell. Cool. So why is it called that? So computer scientists, programmers in general, pretty big lamos historically, and try to sound cool by giving things cool names. Like example, Tenix. No one. That's just some dumb name. Corn shell. Yeah, they try to think they're cool, but they're really not. Also, another reason for why um, things are named really dumb is that storage used to be really small, so everything got abbreviated. For example, like change directory is your CD command, list is ls, that prints all the files that are in there, stuff like that. Now I'm going to talk about real quick the anatomy of what commands tend to look like. So traditionally, here's our prompt at the $sign. It's some program name. Oh, I forgot to fix this from the thing. I forgot to put pauses here, but we're fine. Yeah, it looks like some program name, some options here, denoted by like one hyphen or two hyphens tend to denote if I'm using a full word, and then some list of arguments. So for here, the example is the program we're trying to run is called program name. The arguments are list of and arguments, and the program is run with the A option and the options option. Cool. So now let's get into actually coding some stuff here for a little bit. I think we're going to do a lot of this on Thomas, but I just kind of want to show this example off real quick on my machine. I may every once in a while throw it to my machine as well instead. We'll kind of see here, play it by ear. So let's leave this. Okay, so here's an instance of my shell. I'm currently running Zish, specifically my Zish with with a slightly color modified Agnoster theme. It's got a lot of pretty colors. I like it. You can see my user at this machine is Troy. My machine is called PVC. I like to name my computers after pipes, and I'm at the home directory right now. Looks pretty cool. Now let's check out Bash. This is me recreating my prompt in Bash a little bit. There might be some ways I can be a little bit better. Probably the biggest difference between Zish and Bash is that people decided to make it much more of a customizable aesthetic thing, and that a lot of the things that are enhancements that we might see in Zish exist there as well, but there's not really well, there are ways to customize it, but it doesn't tend to be as like popular for customizer people to do that. The Bash is kind of like people want some power in their command line, but they didn't want to give it too much power and make it like a little bloated, because Zish can tend to be a little bit slow sometimes because of all the features it has. Something that I think I didn't point out, but I want to point out. So tab completing is a thing, right? And I can hit tab multiple times to have it cycle, and I can also invoke arrow keys to do that as well. So I'm going to do that, and then I'm going to go back in Bash here. Okay, and then here's me recreating in C shell. Oh gosh, so I don't know if there's a good way to do this, but literally everywhere I see it, if you change the color here on your prompt, it tends to also change it as well for the rest of the background, and I can't find a good way to reset it, which is also why if we use I'll show you my default normal prompt that I use for Bash and for TC shell, and I think we might show that off here when we go to Thomas, why it looks slightly different. So let's go ahead and go over there. So let's go to Thomas. Perfect. Okay, so right now let's see what I'm running. You can figure out what shell you're running. This has been a feature that's around in a lot of shells, that if I echo $shell, that is a shell variable that can tell us what we're running, and we're running Bash out of the /bin folder. Oh, that is a really good question. So, well, I just saw me point to the screen past me, and it looked like he said something to the extent of, "That's a really good question." So, I'm gonna answer it. What is the difference between a terminal and a shell? So, that's a really good question. I'm going to answer that briefly. So a shell is a program that runs on a terminal emulator. A lot of times we just shorten it and call it terminal. Terminal emulator is any program that allows you to type in a series of commands, interact with your computer in a different way. But we tend to just call them terminals. It's kind of based off of like old school, like from the 60s and 50s, I'm at the computer type of stuff is where we get that terminology from. But yeah, and then let me, oh no, I'm gonna leave. Okay. Oh no. Oh no. Oh, okay, fixed. Okay. But yeah. So we're just hanging out with Thomas here for a second. Oh, some of you may ask, Troy, how were you able? Oh, left Thomas. How are you able to get into Thomas just by typing in Thomas? That's a really good question, and I can actually show you in Thomas because the file that I use is in the same. So, normally, let me go exit again. Actually, if I were to want to go to Thomas, we would SSH Butler username at thomas.butler.edu, and I'm in. Okay. Yeah, that's type. So SSH is like secure something, whatever. Actually, let's see what SSH stands for. Okay, this doesn't tell me what SSH stands for, so I have no idea how to do it. I think it may just be secure shell. But what that command does, it says, I will try to create a remote connection to the following IP. And this, so the IP here is the thomas.butler.edu, and then at Team Wiegand says, I want to log in as Troy. So theoretically, I could, let me exit. I could SSH to just TM Wiegand at butler.edu. Sorry, SSH thomas.butler.edu. And it's just gonna log me in. So the reason why this lets me just go in there just like that is because I have an SSH key set up. So if I were to cd into my .ssh, I have all these different SSH keys in Thomas, and also on my home machine I have a bunch of SSH keys set up. Basically just allows the two computers to talk to each other a lot nicer, and I don't have to type in my password every time. But we're not talking about that in the scope of this video. For this tech talk, maybe we'll talk about it later. Okay. So let's see. Yeah, so everything you run on your computer is just a bunch of, in the terminal, just a bunch of programs. We just have to know where they are. So for example, ls, it's a program. We just have to know where it is, and we can actually find that out by using which. And this tells us that when we run ls, the way that it finds it is it sees that /bin/ls. That's pretty cool. But where does our computer find all this? So most shells use this thing called the path variable. This is a common concept in a lot of places. Windows machines have path variables. Apple, Linux, very common thing. You may just access it in slightly different ways. But on Bash, I access it through the $path. and I can see here all the things that are in my path. Oh, I have a dot in my path? Sorry, let me um, test something real quick, because I didn't realize I had dot in my path. Oh, I do, sick, okay. But yeah, let's run that command again, echo path. A lot of these are gonna look the same. It's gonna be like user local sbin/bin/user, so a lot of stuff like that. Oh, and I'm saying user, but it really stands for like something else that's not user. It's something like shared, like universal shared resources, I think is what /USR stands for. So that way anyone on the machine has access to it, so we don't need to have a bunch of people doing stuff. Like needing to download the same stuff. So in Thomas's /USR, there's a bunch of resources that are available for everyone who logs on to Thomas. I think it is actually universal shared resources. Okay, sick. But yeah, I was gonna talk about why my machine, when I type Thomas, it does that, and it doesn't just, I don't need to type out that full command. So, here is our bash RC here. I'm using Vim to open this thing. I could open it in a text editor, like a traditional text editor, like your Notepad++ or your VS Code, but I'm not feeling like doing that right now because this is command line wizardry, so we're doing everything terminal style today. So here there's a bunch of stuff that we don't really care about. Oh, this is relevant. So, oh, I need to get rid of that. So what this command does is, I really like this one. Oh, and I also have this command, heck. Okay, so here's a couple commands that are pretty useful. So if you add this line right here in line 12, this allows you to just see the directory by typing it. So if I were to go back out here, let's see, a directory I have here is called Butler Junk. So if I just type Butler Junk, it would cd me into it by default. Let's come back here, okay. And also this line, line 13 allows for infinite file size. That's pretty cool. So that way, sorry, infinite history size. So that way all my commands are always preserved no matter what. Okay, let's keep going down. Oh, this is a good one too. So I think on C Shell, this is not by default where it only saves history for your session. This is a command in bash that allows your history to always append it. And now we're gonna scroll down a lot. Okay, so one of the big things, okay. In my bash RC here is this line right here. So, again, I don't think I may have mentioned this properly in this talk. They're kind of all blending together, so I may miss something here and there. But your bash RC is basically a configuration file for bash, so it allows you to do some minor tweaks without having to like re-establish the whole thing, and allows you to make small tweaks on a system that maybe you don't have full control over, and you don't have the ability to like remake the whole executable, or like recompile the executable for bash. That's probably disgusting. I hope it's not. But with guess what? With bash, you can also write code with it. Like you can write scripts with it. So this here says if the file's home is another name for the tilde directory. So for you running on Thomas, it's /home/ your Butler username. For your computer, it's /home/ whatever your username is. So back here on my machine, if I were to echo $home, we'd see it's /home/Troy. Cool. But here, yeah, so if our home is here, then I want to, this dot here, this basically says bring it in. We could also instead here have source, oh gosh, source, and this accomplishes the same thing. And then export PS1. So PS1 is a variable that basically just shell variable in bash that states what your prompt looks like, and this is how you make it look cool like how mine does. So let's quit out here and let's look at my both RC. And the reason why I do this is because I commonly run both bash and zish, and I kind of want to have commands that can run in both in one decentralized place. So that way I can just make changes to one file to update both. So here is the command that we cared about earlier, alias. So I can basically alias things, so that way when bash sees them, it instead runs whatever in the quotes here. So anytime it sees Thomas, runs this. So this is kind of like inline variable substitution. Pretty cool. Maybe not what we always want though. Sometimes we might want something a little more right to the point. So you can also write our own functions. So here's an example. I call it mkcd. So the mkdir command, what that does is it makes a directory, and cd changes you into a directory. So what this will do is in one fell swoop make a directory and cd you into it. Something we commonly want to do, but is not always required, so why we don't want to like alias over cd with mkdir and then cd. Let's see here, there's some other stuff here that I kind of want to highlight. Let's see, what did I do here? Sorry, it's just that past me was more prepared, I guess, than I was. Oh, he did an example of mixcd, so let's do that. So, I don't know if I want to right quit there. We'll find out. Okay. But let's make cd example Jeff. Okay, so we're gonna use Jeff. So boom, we can see here I'm in the Jeff directory. That's what this stuff in our pink here is our current directory, which is pretty sick. Got nothing in here. Let's cd dot. Let's get rid of Jeff. I don't need Jeff. Oh, I can't get rid of Jeff. Why not? rm is the command to delete files. So if I were to touch, which is a command to make files, I don't know, abcdef, we can see I now have this abcdf file here, and I can remove it by doing abcdf. It's gone. I'm gonna move back up to top. But I can't get rid of Jeff with that, so let's figure out how we can do that. So let's man remove. Man pages don't look good with this. That looks better. Okay. So rm, remove the file, remove files or directories. So I give it remove, then some options, and give it file, or files actually. So there's a bunch of, oh, here we go. So if my directory is empty, I can give it just flag D. But if there's stuff in it, I have to give it flag R. So that's pretty cool. So let's go ahead and go back. So let's cd into Jeff. Again, there's nothing in here. So I could just remove flag R, Jeff, and Jeff is gone. Now let's make Jeff again, and let's put some files in here. Let's Okay, so we have made the following 3 files. So if I cd up here, remove flag D should not remove Jeff because it's not empty, but we can give it the flag R to remove it. Okay, and I'm going to show off one last thing from move before we move on to the next thing I want to show off. And this is actually a thing that we can use with a lot of different commands. But I'll use remove as kind of the place where we want to go. So let's make Jeff again. Okay, nothing in here. So let's touch abc.txt, def.txt. Sorry. That was me trying to be cool. I'll show it off later. Okay, touch. I can actually also just do this all in one line by space eliminating. Let me make sure it's actually true. Okay, sorry. Being a little lame. Touch. abc.c++. df.cpp. And let's do that same thing, but with PDF. And let's make an abc.java. Okay, so we have some stuff in here now. So we can actually remove and use some wildcards here. So I could remove in star.cpp, and now we can see our abc.cpp and our def.cpp are both gone. We can also be a little bit more specific here, and let me make a couple more files. So if I do abc1.txt, abc2, and abc34. So let's hope I got the right one here. So if I do abc, and then I think it's just question mark .txt, then that should only count for one space, so it only deleted the things that were specifically abc, one single character, and then that. So that's why I didn't get rid of 34, because it wouldn't match, because I saw the abc and then the 3, but then there was a 4.txt instead of just a .txt. So we can use this pattern matching a lot of different ways. So examples, say I'm going iteratively through some logs or something like that, and I want to delete based off of all the ones from today, then I could just remove, let's see, today is the 24th, so like 24 November 2019. Maybe I just want to get rid of all the ones from November. So say, and there was some like time here. No, say it's only one per day. That's easier. Then we theoretically could just do question mark this, and that would delete like all of the logs for this month. But yeah, pretty neat. So now something that I want to touch on is file input and output. So I feel like a lot of us here are probably familiar with how that type of action happens in a language like C++, where we create a file in stream or an out file stream. And that allows us to do it. So the concept of streams is really important to shells as well. There is standard in and standard out. So commands before they're run will read in from standard in and will then print out to standard out, and then once everything is done being executed, the shell will then print out what's ever left in the standard out buffer. And that's actually how cout works with C++, is that when you're running your executable command, is that it's sending it to that standard out stream that bash or C shell is printing off to the screen. So let's make a quick little example program here in Jeff. Let me actually remove all the stuff in here, which I can do with just remove star. Now we have an empty file. And let's make age.cpp. So we're going to hashtag include IOStream. We're going to have int main. I'm going to use namespace standard for this. So sorry, Professor Barchek, if you're watching this, or if you're learning C++ from that man, you can just use this and not have to put standard : in front of everything. And for the sake of this quick little demo, we're going to use it. So I'm going to cout what is your age. I'm actually going to leave a space here. Okay, perfect. And then we are going to, let's make int age and cin age. And then we're going to cout your age is age. And I'm actually going to real quick here, let me resize this a little bit. Run our code over here on the right, so that way we can take a look at it at the same time. So I'm in Thomas, cd into Jeff, and now let us g++ age.cp. Oh, I forgot to end the program. Okay. Using namespace as oh, I spelled include wrong. Thank you, everyone. Okay. Perfect. And now I can, so I can now ./a.out. Oh my gosh, having a rough day, team. And it'll ask me what's my age. I'll say 21, and it'll tell me my age is 21. Super cool. But what if I wanted to run both these commands at the same time? Which is a question I got asked here, so I'm going to talk about it now at this point instead of talking about the file stuff, and then we'll talk about the file stuff later. So I can run both. I can sequence a bunch of commands all at once by the use of the semicolon. So I could do something like echo abc ls g++ age.cpp ls. Perfect. So now let me remove a.out, and then when I run this command, what? Perfect. Okay, actually I ran it twice, that's why it yelled at me. So now if we run this command, we see no a.out, now there is one. Perfect. But what if we only write commands to run conditionally? So what we can do is, so let's actually use echo again as an example. Give it the flag 76. So, oh, that doesn't yell at us because it's echo. So let me ls. Oh gosh, yeah, so that fails because flag 7 isn't a thing. So if I do flag 7 and just normal ls. It won't try to run the normal ls because it fails at that first part. And this and might look familiar. That's because it is our Boolean from like C++ if we want and. So that works the same. We can also do or as well. So if I were to do this with or, it will run our ls. But now if I flip the order of these commands, and I'll just do a flag 7 this time, it will just do the ls, not print out the warnings. And this works because bash uses what is called short circuit evaluation, which is common in a lot of languages where if enough is known about a statement to determine its truth, it won't do the rest. So for us in discrete 1 right now, or I've taken discrete 1, recall some of our laws. I think it's like the universal something law, where like if I have a variable or truth, that will always evaluate the true, and if I have false and a variable, I'll always evaluate the false. That same type of thing applies here. So we can kind of get away with it. So what is a command we can run right now that is kind of similar to that, that we might want to use? But so we could g++ our ah.cpp, and then we can use and to only run it, to only actually run our a.out if it compiles properly. So 21, my age is 21. So if I go back over here, and let me make this fail to compile again. And now if I run this again, it's going to error out and it won't run. Whereas if I did this, it will do both. And we don't necessarily, we probably don't want that. Okay, so that's pretty cool. Now I'm going to ask people here a question. So have you ever been running a program and trying to figure out if it's working or not, but you maybe had some input at the beginning that you kept on having to put in again and again, and it became really tedious and you're worried that, hey, am I actually doing this correctly? So we can have a way to to formalize this and make this a little bit better. There's 2 different ways here. I want to actually be over here. So we can do 2 different ways, like I just said. So we can use it through pipe and file redirection. So what are these 2 concepts? I'm going to show off the file creation first. So if I have, so let me vim input. So let's call this, let's just put in 21 here. So that's the only thing in the file. And let me make this a little bit bigger here. There we go. Okay. Now if I were to take the contents of input and send that into a.out here, oh, it's trying to execute input. I don't want to do that. So you have to do it like this. Wait, what just happened here? Oh, we accidentally, okay, gotta recompile. So what just happened there, team? Oh my gosh, having a rough day. Okay. So what just happened here, and this is why this is something you need to be really careful about. So in these lines here, so I'm gonna highlight them. So what happened here? I tried to run the command input that failed as a thing and then this took the output from this, which was nothing, and overwrote the file. So we don't want to do this, which is why whenever you're doing file input, you should always do it like this. I was being foolish. So if we do this, now it will skip. So let me run it again real quick without that. So it skipped this input step that's here on this line. Because it was already taken in the input of 21 from our input file. Oh, what's cat? So cat, let's also go back to this profile, okay. It stands for concatenate, but people almost never use it like that. Cat allows us to, if I really wanted to, I could cat input and then age.cpp, and it would do it all in one file. But we tend to almost never use it like that, and by we I mean every single command line human I know will literally just use it on a one file at a time basis, because that's the most efficient way to do that. There's a lot of different ways to print out file contents just to the thing and not actually show it off. Cat's probably the easiest. There's also head, which by default shows the first 10 lines, but I could give it flag n and a number, which I think I need to give it a space for, and it will do that. Tail will do the same, but the back end. So it only shows me the last 3 lines. With the advent of things like tail, really good for checking things I just added, and head's really good for just seeing the beginning of the file to see what's kind of going on in there. Tail is also super cool. So I'll go back to this one to show this off. So let me leave here. So Y is a command. What? Oh, it's yes, sorry. Yes is a command that just streams an infinite series of Y's. So I will show you pipes through this. So if I take yes, sorry, I'm actually still going to show file creation. Sorry, my bad. And if I pipe this into, so remember how earlier we did this to overwrite the a.out file? If I do this, this will append it to a file. So I will send all of this to yes.txt. So it's going to keep doing that because this hasn't run yet. So if I tail flag yes.txt, you can see it keeps following it as more yeses are put down. So this might be relevant. Ooh, that just broke everything. I'm gonna stop this. This might be really relevant for, say, I have a really long-running program and I kind of just want to check on what's going on with it. And maybe it does a bunch of results. So maybe I'm doing like an encryption type thing, and I want to see how long it takes it to bust some encryption. And maybe I have like checkpoints, and I put like those checkpoints in the thing. So it tries, oh, I'll try rot 13, then I'll try Caesar, then I'll try this. Does all of that, and then by the time I get to, I can see like how far along I've made it while my program's running, and I don't have to have it like actively running. I don't need to check on it as hardcore. Sorry there, team. Okay. Exit. I'm gonna come back to Tom's because my prompt got janked. Oh, it's just jank and Jeff. I don't know why that's the case, figure that out later. Is this fine? It's fine over here. Okay. We'll just ignore that for now. Sometimes Unicode is jank, especially if you try to use emojis, because sometimes they'll span multiple spaces and sometimes they'll fight you. We'll ignore that. So I'm gonna go back in. I'm just gonna full screen over here. Oh, perfect. Okay, it's fixed now. So yeah, so we had this input file and we were sending it in, and we always have to remember from my slide here at the beginning that we always start with our command when we're running commands. So that's why we have to do the file input later. So now if I instead want to do it another way, which is with pipes. So pipes are a way to send standard input streams along to another program. So I have some we tend to start with nothing in standard input, then a program runs, has some stuff in standard output, gives that to a different program's standard input, and then it'll print out to the screen the final result. This is most commonly, I think, run with history. So the history command will show you all of your previously typed things. But I could do history and grep for Jeff. And now it'll show me all of the commands I've ever run with the word Jeff in it. I could run all the commands with G++. And I could also do wildcard stuff. So I could do anything with A, B, C. I think it's the exact same. No, it's not. Underscore. There's something you can do to have wildcards. So let's actually figure that out. Do I have to give it the flag W? So the man page is really good for reading, but sometimes I don't want to read. I don't think Thomas has TLDR on it. No, it does not. But my machine does. So I'm gonna open up a new one in TLDR grep to see if there's an answer here for what I want. Not exactly, so I don't want it. Okay. TLDR is a super cool program. I suggest if you run your own computer to do that. Oh, there's also a thing. I think it's called like cheat.sh. Yeah. Okay. So this is basically the exact same thing that was in that TLDR page, but I can instead do this, and we can actually do this on Thomas. So I could curl cheat.sh/grep, and now we'll output what was in that that TLDR page. So curl is a command that lets you check a website and give you back the text content. So if I were to curl youtube.com, it won't let me because I think YouTube actually has curl blocked. Butler.edu. I'll make this full screen. Ooh, I may not like that because I'm already on there. OSU.edu. Perfect. So you can see there's just some raw HTML. I could curl our boy Gupta's site. blue.butler.edu / tilde agupta. /CS151. I need the HTTPS. Let me quickly check something on my machine. Curl, paste. Okay, what did I do differently? Oh, I forgot the slash. Okay, so me not putting the slash here made it think that I was looking for a file called CS151 in Gupta's home directory in the public HTML folder, but putting the slash made it look for the actual directory here. So, for example, if I were to put in project1 sample.pl, I can now just pull up the code that he provided for the example for his Prolog project in CS151 this semester, and then I can take it one step further. Now I'm going to show you here that line wrapping can sometimes get dumb and things get overridden. We just have to be big brained and know exactly what the command was and know that I just need to do a space to append this to p1.pl. So now I've just actually downloaded the thing. If I write ls, I now have this p1.pl, and if I cat p1, I have the program. And I'm actually going to send in a new line to it. So here's another way we might want to use commands to our advantage and file redirection. So as most of us probably know, /n is the escape character for a new line, and I'm just going to send that into p1.pl. Okay, so now if I run cat again, I have a new line. Oh, but somehow also gave it to us. Oh, because Echo puts it on a new line by default. So I could have just done this and get the same effect. So I'm actually gonna bin this file and get rid of that. Okay, perfect. Okay. So back to what we were doing. Oh yes, pipes. So I could also alternatively cat out input and pipe that to our a.out. That has the same effect. We could also do something like echo 21 and pipe that in a.out and get the exact same effect. You may notice that I stopped putting / in front of my a.out. That's because I just remembered that dot is part of my path. So when it runs the command, it says check all the places where executables can be at. By default in Bash, I don't think dot is in it. I think by default dot is in our TC shell prompts. But basically it won't check any directory except for the ones listed in path. So I have to give it the name of the active of a directory that it is, and dot is the current directory, dot is up a directory, tilde is home directory. So let's go back in the Jeff. So that's pretty cool. A couple different ways we can use file input output redirection. But we can also use another command. Someone brought it up during the talk last time, and then I ended up using it as part of my example. We're going to use awk. So before we try to use it, let's try to learn about what it is. So we'll see here that awk, at least on Thomas here, is replaced with gawk. And that's because this is the GNU project's version of awk. because awk is actually a pseudo language type of thing. And it basically just runs a quick awk command, but it's very heavily used for like string manipulation type of things and other things like that. You can read all about it here, but I'm gonna see if we can't cheat sheet the answer for what we want. Oh, perfect. I'm getting colors now. I don't know why awk has colors, but other ones don't. Okay. So, using specific. Oh, perfect. This is exactly what I want. So I want this one right here. Is what we'll use later. I'm just gonna show this off. What does free do? Oh, that tells us how many memory we have. Okay, sorry. Let me run this command again. So what we'll use here is this command to grab a specific thing. So this here, for example, will print just first column. So let's do it with our a.out here. So let's cat input, pipe it into a.out, and then we're gonna run awk, and then it's single quotes, and we have to use single quotes. It's very important that you use single quotes, and double it won't work, because awk, like bash, uses $signs as a prefix for their variables. So all variables in awk and all variables in bash use that $sign, and bash will treat single quotes as a literal string. We'll see double quotes as a string that will have variable interpolation. And I'll show that what I mean by that here in a second. But if I run this command, I now see I only get that first line. But now let me show you what I mean by variable interpolation. So if I were to echo in quotes, in single quotes, $sign shell, it's just going to do that. But if I did it in double quotes, it will tell me bin/bash. And so, for example, if I were to do this, it's just going to print everything because awk kind of failed. But if I do this, it also failed. So don't try to be weird. Just give awk single quote arguments. So that's pretty neat. I'm going to use that with this utility called Fuzzy Finder, which I'll have a link to in a GitHub page with this talk. It'll be on my GitHub. It'll be like github.com/tryvegan/wizardtalk or something like that. So I actually have it jchillin in tilde here. So you may notice man. Let's man. So it's a bunch of manual pages for referencing for stuff. It's pretty cool and gives a lot of in-depth information. May not always be the best for, I know what this thing does, I just forget a syntax thing. But I'm gonna notice there is this flag K here, which allows us to look for a specific manual page. Well, manual pages that I have without actually running man. So if I were to man flag K bash, we can see we have bash, which is our GNU born again shell. We also have some bash built-in stuff, some bug reports, and a restricted version of bash. And it tells us to look back at bash for more reference. We can use a wildcard here. We can use dot to get every single man page that Thomas has. That's pretty cool. So what I want to do is I want to make a script here to help us learn. So I'm going to show off Fuzzy Finder. So by default, Fuzzy Finder just recursively looks through every single folder after it for file names. But that's not what I want to do in this case. But guess what? It takes standard input. So I can do this man flag k dot and pipe it into fuzzy finder. And now I'm selecting from all this stuff, and I could type in here, so I could type like bash. I'm getting matches for things I don't necessarily want. What if I were to type in bash? Ooh, getting a lot of. Let's see if I can't find man. Oh gosh. Let me run this again. There we go. Okay. There's some syntax for fuzzy finder, which I'll pull up here in a second, that can make our search a little bit more specific. But basically, it allows me to type very minimal information to kind of see if I can find a program that does what I want. So if I want bash, and now it prints out the standard output. Now we can use that awk trick that we learned from before. So awk single quotes print $1. So now trying to get bash, I get just the thing bash. So I'm going to show two different ways to do the thing that I want to do right now. So that way we can, in one command, have a searchable list of some stuff, and then pull up the man page for it automatically. So we can man $, bang, bang. Okay, so before I press enter, do anything here. So when I press enter here, what will happen is this will replace what's bash will give me a new prompt with some text with the current stuff, but bang bang will be replaced with the command I just ran. And then so if I do this, oh no, I just went ahead and ran it. Okay. So what happens here is it will evaluate the stuff in $signs first. So this right here, it'll evaluate that, and then it'll give that to man. So that's one way we can do this. So say I want to know about. Oh, let's say I just want to know about git commit. So it tells me about git commit and how I can use that to commit my changes to a branch. Cool. So we can do it like that. We can also, I think we can just pipe this in the man. Let's see if we can or not. I don't think we can, and this is why I did the thing. Because I don't think man, actually no, this should work. So let's learn about ls. Yeah, you see, because what actually happens is that man tries to run before it gets the standard input. So some programs are kind of more pipeable than others, because man will run, and when it sees it doesn't have a command line arg, it just like gives up and can't handle life and calls it quits and goes home. So that's why we want to use this style. We could though alternatively run xargs, and I think I give it like flag I. Let's just do xargs man. And I'll check my computer. I'm also gonna make sure there's space here. And I think this will work. Yeah. So what xargs does, it's a preprocessor, and it basically does what we just did on this line for us. That's all xargs does. You can give it a couple flags to kind of change how it creates this, but under the hood, shots, if you're in one of Robarchek's programming languages or software testing. We can, oh, I've been going for an hour and 5 minutes. This is fine. I'm going to show this off and then I think I'll call it for today. So, yeah, so Xargs does that. It also run. There's also commands, so I can curl. And I can get some kind of fun usage and some stuff that we can get out of Xargs. There are some common use types of things, as well as what some of these flags might do. For example, there might be spaces somewhere and it might try to interpolate things weird, so you can give it this flag I here to force all of that to get put in quotes. Stuff like that. So it's pretty neat. So this command that we ran, I'm going to use this version of it. I'm actually going to put this in my both RC, so that way we can use it. But to be specific and make sure this works everywhere, I'm going to put ~/ because that's where this fuzzy finder command is, because it does not live in, it doesn't exist on Thomas natively. It exists on my computer. If I was really diligent, this is actually what I'm going to do, and I'm going to expect you to do this. Something that a lot of people do, and I'm actually just going to point this out right now and show this off by going to my computer, closing out this. So a lot of people will do this. They call them their dot files, because your bash RC, your C shell RC always start with dot because they're by default hidden files. So if I were to ls flag a in here, you can see I have my Z shell RC, my C shell RC, my bash, and my both RC, and in the RC, of course, because everyone knows it stands for run commands traditionally, or at least why I first started calling it that is because when you run the thing, it runs those commands. Kind of a dumb little trivia tidbit that I honestly didn't know till right now when I looked it up. But a lot of people will essentially have like this sort of file, and people will put like scripts and stuff for different configs that they care about and just symbolically linked to it. Because like right now, if I were to ls flag la, oh wait, I just want my I just want to show off my bash RC. So if you see here, it has like this pointer to .files.bashrc. So this program, so this file in my home directory is really just a pointer to this other thing. So that way, if I ever try to open one, it will just send me the .files. And so that way, I can just have everything in one place and a lot more easily updated because it's only in one folder. And then once I set it up, it's all pointing there. So if I make some update configurations, it's only as simple as going into my .files folder, and then running like git pull on it or like git commit, and now it's in my .files repo. I really need to clean this up because I have a lot of scripts in here that do different things. So like the mansplain one, for example, this is kind of does what we just did with fuzzy finder, but does it on a, oh, I think it's just WinM. Yeah, it does it on a full computer level on my machine. So example, if I wanted to look up Xargs, and then just puts it in like a PDF over here for me to read, and maybe I want to copy stuff from it. then I can do that. Um, Fun, um, nice little thing that I thought of, and I ported it over to here for that. But I'm actually going to put Fuzzy Finder, because I don't do this on Thomas because I'm lame, but I probably actually really should. So that's going to be something I do later. But I would suggest, if we're being good, diligent people, that's what we do. But for the sake of time, I'm not going to do that right now. And I'm just going to make sure I include this. Cool. List open files. So that way it runs anywhere. So say I'm in my public HTML. Public HTML in this graphics folder that I have no idea what's in there. Oh yeah. And then I try to run this command, it still will work no matter where I'm at. So let's go to tilde. And let's, I'm going to be lame today, and I'm just going to copy it and paste it in. Or I'm going to find one that fits all at once. Okay. And now I can vim my both RC. Oh, and I have a different version of it here. I would call it Fuzzy Man, which I have as a function here. Let's try it as an alias, because I think the reason why it wasn't working before was because I don't know how to type. Was because we were using this version and not the other version. So let's try Fuzzy Man equals quotes. So now I'm going to run source on my bash RC. We could also accomplish the same thing by exiting out of bash and reinstituting it, because every time we log into bash, it will run our bash RC. Or you just run source to resource the same session. So now I should just be able to invoke Fuzzy Man. Oh, it tried to do a bunch, so let's just do the function version. Sometimes this happens where things are more easy as functions than they are as aliases, just due to how things process things. Let's put a space here. So this is something you could theoretically put in like a .shell file or something. If maybe we had a lot of variants of it, and then had like an if statement that said, if I have this flag when I run the executable, do this. If I have this flag, do this. So let's resource. I have a broken token somewhere. What did it say my error was? Oh. Let's just do this. Do this. Do this. Everything looks fine. Sometimes this happens. Unexpected. Everything looks fine to me. I don't know why it's doing this to me. Does Jeff work? Yeah, Jeff works. I don't think this is an Xargs syntax issue. I think this is just something's being dumb, and if you can correct me at home, go ahead and do it. But yeah, so we can just have that there, and then it'll always work. And we can also do the same thing with the cheat sheet thing we had, right? So let's do that as well. So if I were to curl cheat.sh / bash. Oh, it gives us some cool basic stuff of how to do some for loops, how to do some commands, how to do some redirection. Pretty heckin' cool. So what we're gonna do is let's vim my both RC here. Let's go all the way to the bottom. I'm gonna get rid of this. And let's call it cheat. Actually, I'm gonna call it no. I'm just gonna call it cheat. And then this runs where I just curl cheat.sheet / do I want to put it in quotes? Nah, I think I'm just gonna put $1. So let's see if this works. Not what I want to do. I want to source. Perfect. So now if I were to run cheat bash, we get the exact same thing. So now I can run maybe cheat on some commands that I want to know to get that. Let's see here. Oh, wrong thing. Let's see if there's a way to list all of the cheat sheets, because this might actually be more relevant than I'm gonna pause real quick. Okay, I think I'm back recording. Okay, perfect. So I've just also seen we can do this, and this will give us a list of all the things that we can cheat. So we can actually just run the exact same thing we just did. So I could pipe this into tilde/fuzzy finder. And let's say I want bash. And then we could pipe that into cheat. Oh, this is not good. I think it just ran all of them. Yeah, okay. That would require a little bit more effort and nuance, and I will leave that to you at home as a challenge about a way to fuzzy finderify cheat sheet, so that way it's a lot more easier to see all the stuff you want to care about. A few more closing sentiments. Yeah, this is really fun. I'm glad I got to re-record it, actually, because we didn't show off this cheat sheet thing before, and I think there's a couple of other things that we showed off here that we didn't show off in the other one, because this one was really time boxed due to the fact that I had tutoring at 7. Let me actually look at you and not at the me that's on that seeing the output from. But yeah, I think it's really cool. Really want to encourage anyone that's watching this, if you want to do a tech talk with the Butler ACM next semester, to reach out to me, to Ryan Graham or Jack just blanking on his last name. Jack. Um, and do that. This was just a fun little dirge and command line stuff. Maybe you might find something else is super cool in the command line to do, or maybe you want to talk a little bit about X feature in a language, or you did some cool project and you just want to do a breakdown of that and like, hey, did this super cool project over winter break, and I just kind of wanted to share with some people how I did it, and like, these are all super cool things that we really want to hear about, because we really just want to build ourselves up. So our curriculum here at Butler is really great at helping us learn how to learn CS stuff, but not really actually doing a lot. I think in general that's something that a lot of our faculty will echo. Um, and these type of excursion, like these type of events, learning about some different language or learning about how to do some cheeky little things on the command line, learning about Docker, is a really good place for us to really help each other as a Butler community improve. Also, some final remarks on this talk. It will be up very shortly. Well, if you're seeing this, I have it uploaded on YouTube. Probably youtube.com/TroyWeekend. I think that's where my channel lives. But no matter what, resource files, not github.butler, just at normal github.com. I will have made a new repo called Wizard Talk or something like that. That will have the link to the fuzzy file, the fuzzy finder, and some of the things we briefly talked about. So things like MKCD, the quick little shell scripts we wrote, and some of the files. All that will live in that talk, as well as maybe a few relevant memes, and also maybe a few challenge problems I'm gonna press as maybe some next steps to explore on your own. I'll throw a couple things in there like that. That link for sure will be in the YouTube description of this video. I'll also have the YouTube link for this video on the GitHub. So a lot of cross-brand synergy. But again, thank you so much. I really appreciate you watching this video. Hope you got some stuff out of it. And I hope if there's someone who was at the original talk, that this was better and maybe they got some more out of it. Yeah. Have a wonderful day.